Okay, so let's have a look at a internal rate of return problem, question 23 in the text in chapter 7. We've got a question here. There's two mutually exclusive investments. We're given 3 years of the investment life cycle, and we're given 4 cash flows, one of them being the upfront payment. There's no function given for those cash flows, so for all we know they're just completely arbitrary numbers where cash flows in and out of that project, not related to a consistent interest rate by any means. So as a result of that, we're going to actually need to use the trial and error method to calculate our internal rate of return, and the reason for that is that we need to calculate net present value for a number of discount rates until we find the discount rate that gives us a net present value of 0. Now when we have a discount rate where the net present value is 0, then that discount rate is our internal rate of return, and you recall that from the text. So go through the text further if that's if you're not quite sure about that concept. That's very important. When the discount rate achieves a net present value of 0, that is the internal rate of return. So we do that through an iterative process or a trial and error method, and you can use a financial calculator in many cases. Many of them will have that function, and Excel has that as a function as well. And you will be able to use your financial calculators in the exam. So if you can work out how to do that on the financial calculator, that could be to your advantage. Now, what you will find though is that there might be exam questions that do ask you to show steps of this process. So you might not be able to just use the function in a financial calculator to answer the full question. So you need to learn how to do it manually as well. And the important thing here is that even though you can punch in the numbers to a calculator, you've got to understand what we're actually doing. And so let's go through that now. So you will recall that our net present value formula is this one, okay? Future value divided by 1 plus r to the value to the power of n. So in this case, let's work out the net present value for the total investments. We need to do this for every year. So we can start out here, and we'll start up with our first one. There's no discounting because it's the minus 750. The 750 cost of investment is an upfront payment. We add our first year. So the return on investment in the first year is $200, and we divide that by 1.1. It's to the power of 1, so it just equals 1.1. So it's 1 plus the rate. Now we add our second year, and that is the return on the investment in the second year is $400, and we discount that across 2 years, so 1.1 squared. And our third and final year, we're looking at LIMP here, obviously. I don't think I mentioned that to begin with. We're looking at LIMP investment, and our third year return is 700, and we discount that across 3 years, so 1.1 to the power of 3. And what we end up with here, now, and if I didn't mention, the discount rate we're using here to begin with is 10%. So we're going to need to use a number of different discount rates in order to narrow down what the internal rate of return is. So the discount rate we've used at 10% creates a net present value of 288.32. Okay, so what we then do is we can go on and create this table by calculating the discount rates at various levels. And what we can see from this is that the net present value exceeds or goes below 0 between 20 and 30%. So therefore, somewhere between 20 and 30% we know the internal rate of return for LIMP is. And STUMBLE, it goes below 0 between 30 and 40%. So we know somewhere between 30 and 40% it is for Stumble. So we can sort of do some averaging and work out how to target the discount rate better than just going 31%, 32%, 33%, so on and so forth. But what I believe the answer is around 26 for Limp and 38 for Stumble. So you can see that in the answers, but this workings it demonstrates how to actually arrive at each of the numbers in this table. So it's quite a long process, but it is important that you are familiar with this basic function here for net present value, which can then allow you to elaborate in the full equation to calculate your NPV for a full investment at a given discount rate.